All right, so I'm going to talk you through a more complex example where you're given a series of points, their images, and then are asked to find the transformations and thereby the image of another point. So these are the points you're given, and using our mapping notation, we'll say that this point 1, 0 maps to 3, minus 1. We've also got the point 0, 1 maps to minus 2, 4, and we're asked to find the image of the point minus 3, 5. So we'll put that to the side there and we'll just leave it for now. We'll deal with this first. So we're given these two points and their images so that we can assess what the transformations actually are. Now, the book goes through a fairly lengthy process, which I'm going to talk you through, but I'm going to also give you a shortcut method, which I discovered today as I was making this video. So the shortcut method says that this is our basic transformation matrix. All right, and there's a 1 up in the top left because it applies to the x value. There's a 1 in the bottom right because it applies to the y value. And there has to be a 0 there to make sure that there's no y happening in the x and vice versa. Additionally, if on a side note, if you happen to see a value in either here or here, that's what's called a shear transformation. And it is where you anchor one axis and move all other points a certain dilation. I'll show you a picture. And this is nothing that you need to know or remember. I just wanted to explain it because I like to put things into real world context. And there's a few examples in the book that you'll come across where there are actually values in these positions here. And from what we already know, they don't make much sense. But using this information, they do make sense. So this is the original shape, and we're dealing with shapes here because at its heart, matrices is 2 dimensions. You have an x and a y, so there's shapes. All right, so this is the original shape. This is where we anchor the y-axis and push everything else a certain factor in a certain direction. And this one is the opposite, where you anchor the x-axis and you push all the other points in a certain direction. Now you'll notice for y shear mapping, you anchor the y-axis and then everything else moves vertically, and that's how you get this skewed shape. When you x shear map, you anchor the x-axis and everything else moves horizontally. All right, so this means that when you see this numbers here or here, you can assume that they're moving in a certain horizontal or a certain vertical direction. But again, we don't need to know this. I'm just trying to explain it so that you're understanding what numbers are showing you in the matrices. All right, so to move on, we're going to go back to this example here and the shortcut that we've discovered. So remember, this is the basic transformation matrix, and what I want us to look at is this. So this here and this here. All right, now if I was to transform the point 1, 0 by a transformation matrix, and I'll just write it in the right order so that I can do the multiplication properly. Remember that transforming points using matrices runs off matrix multiplication. So I'll use just the basic transformation matrix, and I'll transform the point 1, 0. So remember, this matrix here is the basic one. It shows no change. So if I put this point through the multiplication, I'll have this row by this column. So I'll have 1 plus 0 in my top position, and in the bottom one I'll have 0 plus 1. So therefore the point hasn't moved, which you can see. Now what I want you to compare is this column here with the answer. They're the same. All right, so if we try it again, we'll do 1, 0, 0, 1, but this time I'm going to multiply it by the point 0, 1. All right, and I'll rows by columns. I'm going to have 0 plus 0, and in the bottom row I'm going to have 0 plus 1, which is just 0, 1. Now compare that to the second column in the transformation matrix, and you'll see that they're the same as well. All right, so this is, I won't go into any more detail, but what you can understand from that is that in the transformation matrix, the first column shows you either the point 1, 0 or if it shows the transformations that have happened, it shows you where the 0.10 has ended up. And the same thing for the 0.01. All right, so those can be two reference points that you can use to help you with your transformation matrix. So now that's the shortcut. I don't expect you to master that now. I'm going to show you how it works in the context of this example, and I'll show you another way to figure it out as well, so that you can have multiple strategies up your sleeve. So shortcut way says, I notice that these 2 points are precisely the 2 points that the transformation matrix references. So I can just plug in their final results in a matrix format, and that will be the transformation matrix that every point undergoes if it undergoes the same transformations as happen to these 2 points. All right, so if I just multiply my new transformation matrix by the new point that I want to move, I'm going to have rows by columns, and it's going to be so it's going to become, I'll just move this to the side, it's going to be 3 times minus 3, which is minus 9, plus minus 2 times 5, which is minus 10. All right, and then in the bottom row, it's going to be minus 1 times minus 3, which is 3, plus 4 times 5, which is 20. So I'm going to have a new point of minus 19, 23. All right, so that's the shortcut way, the way where you identify the fact that you have the 2 points, the 2 reference points that appear in the transformation matrix, 1, 0 and 0, 1. You just plug in their final results into your new transformation matrix in the relevant positions, and then you multiply the transformation matrix by the point you're trying to move, calculate the results, and that will be the final location of the point you moved or transformed. All right, so that's the shortcut way. Fairly straightforward, but it runs off the fact that you have to be given these 2 points, 1, 0 and 0, 1, and you have to know their final locations, because these are the 2 points that are referenced in the transformation matrix. No other points are referenced. So if you're not given these 2 points, this method won't work. All right, so moving on to the longer way of doing things, and it runs off using each point individually and working out what its transformation might be. So you're going to have your basic transformation matrix with no information in it, just positions. You're going to multiply it by the point that you've moved, and you're going to say you already know the answer. It is 3 minus 1. All right, so all we need to know there is that if this times this equals that, so we're going to have 1a plus 0 times d equals 3. All right, so a times 1, oh sorry, not d, it was b, wasn't it? Just erase that so it's not confusing. All right, d, all right, so it's going to be 1a equals 3, which means that a equals 3. Okay, so that's the first one. The second one is going to be that we're going to have 1c plus 0d equals minus 1. All right, and then again this cancels out and you have c equals minus 1. So that gets you a and c, but it won't get you b and d. And to do those two, you're going to have to set up the other point and multiply it by the same empty matrix. All right, and the point this time is 0, 1. And we know what it equals. It's moved to minus 2, 4. So again, we're going to have 0a plus 1b equals minus 2. So therefore, b equals minus 2. We're going to have 0c plus 1d equals 4. So therefore, d equals 4. All right, so our 4 numbers now are 3, minus 1, minus 2, and 4. And all we have to do is to plug them into their relevant positions. So it's going to be 3, minus 2, minus 1, and 4. Now, if you come and compare what we've just found using algebra with the shortcut method, you will find that they are the same thing. So 3, minus 2, minus 1, and 4. All right, so this is the way you're going to have to work if you are not given the 2 reference points, 1, 0 and 0, 1. But if you are given the 2 reference points, you can just plug in the new images into the transformation matrix in their relevant spots, and hey presto, you have yourself your transformation matrix. Now, from this point here, once I found the transformation matrix, which tells me what all the transformations are, I would then go through the same steps as I did up here, multiply it by the point, which was -3, 5, go through the multiplication, and the answer I would find would be -19, 23. The final step would then be to make sure that you would to write something like this, where you had shown that the point that they gave you mapped to the new location, or in their one they say the image of this is that, but that's what this little arrow means. Remember, in our earlier work we learned that the arrow means maps to. So get into the habit of using your notation, because it saves you a lot of time in the long run.